Good morning, YouTube. It's Leo. So if you've been following this channel for any length of time, you know that I recently got this Arturia Keylab 61 keyboard, and I love it. And one of the main reasons why I got it is that it's got CV, gate, and modulation outputs on the back, which makes it perfect for using it with your modular synth. There's a small problem with my plan here, and let me show you what it is. My modular synth is all the way back here. I cannot reach it from where I sit when I use the computer. Right? I've got my sequencing software over here, the keyboard is down there, modular synth is way back here, which it might seem like a small and kind of petty problem, but every time I have to get up, walk over here to make one patch connection or to change something and then come back and sit down, it's a bit of a pain. And when you have to do it hundreds of times in the course of one session, it adds up. Human nature being what it is, I get lazy, I end up not doing the things that I know I should be doing. Now, we swing over back here. If only there was a solution, if there was some way of building, a custom Eurorack case that fits this keyboard, that does exactly what I need and brings the modules sort of up where I want them. If only there was a way of just designing. Oh wait, hang on a minute. Wait, it turns out that that exists, and that software is called Fusion 360. And actually, it's free for hobbyists. You can design things and get things catted up and ready for manufacturing. Okay, so we've got that, and that's great. But how am I gonna make the thing? I mean, I can design it in the computer. If only there was some way of, taking that part that I've designed and sort of machining it somehow in some kind of machine like that one. It's a low-cost hobbyist machine that will cut anything out of wood and certain kinds of metal, and it's extremely high precision. Well, that's absolutely amazing, because then I could use that to actually make like a case that sort of fits the needs of my keyboard, kind of like this one. I would design a thing like this, and it would fit my keyboard, and it brings the modules right where I want it, and my monitor would be up here in the back, so I could angle it and pull it up and over, and I could see what I'm doing, and this would be a pretty ideal setup. So in this video, what I'm gonna do is show you how I got this to happen. And I'm gonna walk you through all the steps of manufacturing this thing. It's gonna be a two-part video because there's a lot to do here. But stick around, hopefully you'll learn something about CNC and see how I put this thing together. Cool? Let's do it. So let's imagine we've gone back in time. All we have right now is the keyboard and this aluminum rail. These are the things that hold up your modules inside your case. I'll talk more about these later in the video. Now all I have is this, and I realized that this actually fits almost exactly with the width of the keyboard, which is cool. If you put some end cheeks on it, it'll potentially really match the look and feel of the keyboard. I did not know anything else. I didn't know what shape I wanted for the case. I didn't know if I wanted the modules to be sticking up and have a low profile, or have it a little bit higher up and facing forward so you have easy access and visual sort of sight lines to all the modules. These were all things that I iterated in a notebook. It's very low tech. You have pencil, you have paper, you figure out the spacing for the holes and start coming up with different designs and see what works. And ultimately I settled on the design that you see in the intro of the video. I liked it because I could put my pedals and stuff under the actual modules and have the keyboard in front where I like it, and all the cables and things can go under the case and back behind the desk, which for me is brilliant. I like having a clean, sort of tidy setup. That was the design that I came up with. Now, I'm not going to go into a tutorial on how to use Fusion 360. I think there are plenty of really good ones on YouTube, so you can look that up and learn how to use the software. The rest of this video, we're going to go over how to actually make that design from Fusion 360 into a finished case. All right. So there we have the CNC machine. And here we have the UC CNC software that we use to control that machine. Since I just fired it up, the first order of business is to hit this home all button. You see it moving all the way back to the edge. Okay, it's very important that that machine is calibrated so that that position in the back left corner all the way at the top is the 0 position. And we just did that by pressing the home all button. And now that the machine is homed, let's take a look back here again. What I'm gonna do is just load the file that we created in Fusion 360. And I have two separate files for the left and the right cheeks. So if we zoom in here, you should be able to see that you can actually take this and rotate it around and see what the object looks like in three-dimensional space. And you can see the head of the machine. This is where the end mill is. You can see the path that it's gonna travel, and you can zoom in and take a look at exactly what it's gonna do. So here we have the part in Fusion 360, and you can zoom in, you can take a look at it from several different angles. This is the left cheek. I can't fit both of them into the CNC's bed, so I'm gonna have to mill these separately, and that's okay. And if you look, there are multiple steps in this project. There are multiple tool paths. So first I wanna cut the pockets for where the washers will go. And the second step is to actually drill the holes all the way through. And finally, I wanna cut the contour of the part all the way around. Now you'll notice that I'm not gonna cut this all in one go, but that I'm gonna take multiple passes and work my way through that material. If you take a look at the setup for this part, you can see that the material that I need to cut is actually here. So this would be a representation of the overall MDF stock that I'll be working with. And you can see that the part is gonna come out of that stock like this. And if you edit that part, you can actually see what dimensions they are. So 221.4 in the X dimension, and in the Y dimension, it's a little bit taller, it's 276. And so now that I know that, I'm going to go over and dimension my MDF. This panel that we just cut is a little bit wider than we need to cut out the left cheek. It's a lot longer, but that's okay. I can use that for other projects. The cheek will come out of this, and we need to secure this to the spoil board that I have down here. Let me show you a cool trick that I learned from one of the people at the forums for the Stepcraft CNC group. Now I used to secure my stock to the bed of the CNC machine using all kinds of metal clamps and stuff. But on the Stepcraft forums, I discovered that this is actually completely unnecessary. If you have strong double-sided tape, you should be able to attach this stock to the CNC machine, and it will provide more than enough grip to hold this thing down as it's being cut. Alright, so. And you'll see that I put it on diagonally so that the tape will actually cover all of the strips. This way you end up getting good grip across the surface of the stock. Alright, so we're gonna give that a second to really stick. And once this thing is on here, you see that just how much sort of force I can put on this thing, and it does not move. So it's actually quite an effective way of holding it down without having to use clamps. As you mill things, especially MDF, it tends to generate quite a lot of dust, which is why we have this whole dust extraction system set up. Let me bring the gantry over so you can see it a little bit better. Okay, so this hose here, this is going to get attached to our shop vac, which I'm going to do here, like so. And that hose internally leads to this assembly down here. And this can be removed. This is called the dust shoe. And what this does is it pulls a lot of the dust away. It's not perfect, but it keeps as much of the dust as possible away from the CNC machine to keep things clean. Okay, so the next step is to make sure that the height of the end mill, when it reaches position 0, it is exactly on the surface of this workpiece. If it's too high, the end mill is just going to be cutting air, and if it's too low, it's actually going to cut too deeply into the surface of the workpiece, and that could damage the end mill or damage the workpiece or just give you a result that you don't want. There's ways of doing this manually, but I bought this optional, this is basically a little micro switch here. And what this does is it's very precisely calibrated so that you bring the end mill down until it's right over the switch, and you simply hit V. So what just happened here was that it went down until it touched the switch and engaged it, and then it backs up and does it even more slowly, so that as soon as this switch engages, immediately it sets itself to 0. This distance is known, so this end mill is now calibrated so that the tip of this is actually on the workpiece. Let's close up the enclosure and we should be ready to start milling. All right, so we've got the machine. Everything is in there. It's double checked. All the software is double checked. Things happen fast on CNC machines. That spindle is spinning very fast and the machine's moving around. So if something goes wrong, it's very likely you'll lose your workpiece or sometimes the end mill. So it's important to double check everything before you hit the go button. But I've done all my checks, everything's looking good, so I'm gonna go ahead and hit that cycle start. And there we have one perfectly cut end cheek. Yeah, open this up. Now a little bit of dust is gonna get out of there. That's inevitable. So what I like to do is just vacuum that up. And finally, all that's left is to liberate the workpiece from the CNC machine. Now, depending on how much tape is in here, this may be easier or harder. This seems to be going okay. That, and I try to do this in a way where I don't mar up either the workpiece or my bed, but sometimes it's a little bit violent. And there we go. And so there's the tape. This will come off nice and clean, just like that. You wouldn't know there was anything there. So here we have the milled part. Look at how cleanly that stuff comes out. Such is the power of computer-controlled systems. Now, what I have here is an M5 washer. That is an absolutely perfect fit. The fibers of the MDF are holding it up, but there it is. Look at how precise that is. And if we take an M5 screw, it's an M5 screw, 5mm, pass it through like that. It fits right up to the surface as we've designed with the pocket, and it comes out on the other end, and I think I'm pretty happy with that. What I'm going to do next is do the same thing on the other side. Here we have the milled side and the other side. So these come in a pair. And these are the rails that we're going to use to mount the Eurorack module. These actually come in pieces. So there's this threaded rod, it's a threaded strip of M3 holes, and then there's this aluminum profile here. On the edge, and this is made by a company in Germany called G-Tech. There are others that make it as well. These rails all conform to a European standard for I think test and measurement equipment. So the mechanical side of the Eurorack specification is actually based on this standard, and you can find different companies that make these rails. I got these as part of a group buy. They are 168 HP across. so that you can fit 2 Doepfer cases worth of stuff in every row. And as you can see here, there's one 3U and one 1U because I have a series of these IntelliGel modules that I want to put on the top for utility. So let's go ahead and take these M5 screws with the washer, put it in here, and then screw this onto the rails. All right. So here we have it. We have the rails attached to the end cheeks. I haven't cut a top for this yet. There's no electricals. This is literally the first time I'm seeing it, and I have to say this is not too bad. As you can see, these rails are almost exactly the same width as the keyboard, which is what actually gave me this idea. And it looks kind of cool, sort of up and over the back of the keyboard. And again, since this keyboard has gate and CV controls on the back, it is really useful to have a modular synth right in front of the keyboard. So in the next video, what I'm going to do is actually cut the top, figure out a way of installing the power distribution system to power the modules, and cover this MDF with some sort of nice fabric or some sort of vinyl material. But this is looking quite okay. I'm pretty happy with how this is turning out so far. All right, so that's the end of part 1. Thank you so much for watching. I have part 2 already shot. I'm in the process of editing it, and I'm hoping to have that out within about a week. So if you've enjoyed this, please hit that like button, hit that subscribe button, maybe hit that little bell icon so that you can be notified when part 2 comes out. If you've got any questions or comments, please leave them below and I will do my best to answer them. And thank you so much for watching. I will see you in the next one.